front view. The perspective is almost identical to the original first sketch that was made. Little notable differences are there was a flare between the bubbles that was removed, and the nose was brought forward. And the trend and styling was to have the body be very low for low, wide, and long look. So a pear shape would tend to lead to a very heavy design. To offset that, I worked out the arrangement of the quad fins so that the upper fin assembly, in a sense, lifted some of the weight off of the body. The lower quad fin provided a slight lifting force to reduce weight. To further lighten the body view, the surface was artificially reduced in size. By carrying the body section at the passenger area, that gives the dominant effect of the mass. Coming out of the air scoop, there was a return down flange which picked up an additional ½ inch or so to lighten the vehicle. If the body was carried out to the original shape, it would have been like adding about a ½ inch of fat to the entire section. Additional details were developed to add motion to the body section. The fin assemblies, the blisters, and the quad tail fins and the 3 tail fins are all progressively canted further and further aft. It's like a progression of falling dominoes, and this leads towards giving motion to the shape. The original design basically only had the 4 quad fins, and there were no tail fins at the aft. But at the time of doing the string drawing, Stefan Hepsberg added the large dorsal fin and the 2 lower side fins. Now at the time, this appeared to be a problem because it was a violation of trying to merge a tri-element feature into a quad element feature. But the mass seemed to work properly, and so we retained it, and this was incorporated in the space frame mock-up. As it finally worked out, the resolution of the 3 fins worked rather well, integrating into the side bodywork. The trailing most lower fin was made to line up to the widest point of the body section. That would be some form of logic, and the tail fin, of course, was able to be on center line. And then that resolved to working out the details and the blending from one detail to the other. At the time we were working it, you note that the rear wheel is actually larger than the front wheel. And in our initial development, we requested of research staff that they modify the chassis so as to move the rear wheel forward about 3 inches. They came back with a response that no, they couldn't move it forward. In fact, they would have to move it back 2 inches. As a result, the car appears to be a little bit hippie in this area above the rear wheel. The resolution and the fine definition of the surfaces, great credit has to go to Larry Seamy, who is the head modeler. He had 3 students helping him, but together we worked it out so that the surfaces changed slowly from one detail to another. You can see it as it undulates. Once the surfaces were worked out, the body panels were defined by scribing specific lines. Those on station were simple. Where we had to go to, say, the top deck arrangement, we had to cut some special lines, and Larry Seamy gave me a large clay modeler's knife in which I was able to scribe in the deck openings. After the body surfaces were pretty well defined and the deck openings located, research came back and indicated they needed an additional inch above the engine. Now, rather than enlarging the entire section to accommodate that, I was afraid that I'd add too much mass. Therefore, I added the clearance necessary totally above the engine only, flaring from the deck opening itself. The engine exhausts were dumping out directly over the engine from the regenerative units, and for this we have 2 polished polished stainless steel exit ducts mounted directly on the engine, and they penetrate the body. Underneath the deck is a stainless steel insulated liner, provides a smooth surface, and there's a small gap between the bodywork and the exhaust to get a venturi action to draw air from the bottom, which is a louvered assembly. Underneath the deck, on the right-hand side is the fuel tank, and on the left-hand side are the electronics and the relay switches, which are accessible from the other side fender. The deck over the engine is hinged to swing upward, basically between the dorsal fins. Just after the dorsal fins is a secondary rear deck assembly, which hinges up to give access to the differential transmission, engine or transmission braking drum, and hydraulic systems and suspension. Immediately after that are the air brake systems, which are mounted one on each side of the dorsal fin and one at the lower assembly. Another view of the panel breakups. You can see the brake on the top side for the two panels. Actually, they open up scissor fashion. The lower panel is the hinges up and provides access to the relays. Immediately forward of the back panels, we have the passenger compartment. The doors are designed to swing upwards, a little bit Mercedes fashion, except the axis is skewed so as to lift the door upwards and forward. And you can notice that the blister is split on a bias, and you'll notice that is in a very slight canted plane to also match the progressive series of slant backs of the other fins. Then of course the door is cut to provide leg space, and the aft part is not needed because that's right where the person is sitting anyway. Immediately behind the passenger is the intake. And the intake is set so that air coming in from one side actually joins a fiberglass tunnel that bridges clear across to the opposite side. This whole duct is attached to the space frame box structure in such a manner that when the engine is located at the center, that the engine protrudes into the box forming an acoustical chamber to quiet it, and the air is basically supplied from these two sources through a connecting cross duct. In a little better view is the exhaust system. Each of these exhaust ducts penetrate the body surface to vent directly upwards. They're located essentially between the upper quad fins to keep people away from it. In fact, the temperature is reduced quite a bit after having gone through the regenerative drums, and I was able to actually hold my hand comfortably about 1.5 feet over the exhaust while it was at idle. Continuing forward, the bodywork was arranged so that the trailing arm suspension had a clean mount beneath it, and a small fin was added to give it clearance. Beneath the nose, there were two magnetic coils that were set up for automatic guidance of the steering system. Since the steering was a joystick controller device, all it took was electronic signals to steer it. So two magnetic coils would descend from the underside and pick up and sense a wire in the roadway, and that would provide the steering input to the vehicle. Forward nose assembly was actually one of the very first elastomeric urethane bumpers, one of the first ones to be actually used. Inside the central area was a grill work of aluminum parabolic sections that would be illuminated by a neon light for an equivalent of a low beam. Just outboard of the low beam were a pair of high-speed spotlights. The front nose fender, small detail, is the turn signal, which is located beneath the transparent matching body paint. An auxiliary engine power unit was located in this front assembly. It would drive a 110 volt AC generator for powering electrical systems and 3000 psi hydraulic system using Skydroll materials. For the Skydroll, a new polyurethane paint was developed, and most of the interior components are of the Skydroll. The novel feature of the APU unit was that the 110 volt generator could be plugged into a house current when it was on display at the Waldorf Astoria or whatever other shows, and therefore they were able to power up all the subsystems and demonstrate the hydraulics and the electronics and everything else without having to start an engine inside the compartment. In other words, the generator was just run in reverse as a 110 volt motor. Other details and features, the wheels were cast aluminum mag alloy, I'm not sure which, but they worked like a centrifugal blower. This would be the inlet on the exterior side, and the air passage would sweep upward and outward to the drum to cool everything, and then just a vent on the inside. But it's working essentially like a centrifugal pump. Here we have a slightly closer view of the interior, as best as we can get here. You can see the slant back of the pilot opening. The hinge lines were located right in this area, and both blisters, when they swung upwards, would almost meet on the overhead. At this point, this pretty well wraps up this overview. This is a lunar vehicle that was built at GM DRL shortly after I left. Did work on these wheels, working on the wire support system, suspension, drive system. Uses a slip frequency AC drive in the motor, running to a harmonic drive in order to isolate the bearings from the vacuum. The tread patterns were woven into the wire so as to provide some bearing strength. The tire in contact with the ground would deflect and the wires would give support. Because the gravity is only 1/6 on the moon, the wires are designed for a very light vehicle, only 1/6 the weight, the actual weight. The problem was if the vehicle were to run into something, the pull inertia would impact and probably collapse and permanently deflect the wire. Therefore, they put an inner frame inside to stop it from overloading, overstressing. Here's the joystick controller that we picked up from the Firebird 3. A better view of the contact strips that are riveted into the wire structure, and they pantograph right along with the wire. The fenders were intended to keep dust from flying up on top of the electronics radiators, which are radiating in space. That would have caused overheating and caused them to return to their mission, complete their mission much shorter.